to the rescaling, you cannot rescale up to some amount the bad frame. This is one issue. The second issue is that you cannot do standard place and route or SDL here. You cannot do it because SDL cannot recognize that you should this core should be inside the frame itself. So what I have did here is just uh, imported or instantiated a ring oscillator, which is the core, and the bad frame inside one cell. I call it chip here. Yes, this one. You can see the small like a capacitance here is my core, and here is the bad frame that is coming with the technology file or the technology that we are using. So in order to I cannot reduce it more than this. It seems to me that this is the minimum size for the bad frames that we are allowed to use. I'm not sure about that, but it really cannot scale more than this. I cannot reduce it. I cannot reduce the bad frame dimensions more than this. So let me just zoom to the core. Yes, you can see here. Here is my two inverters and the NAND gate. And here, because I have this crossing, they said because this is VDD and this is ground, I cannot use the same metal. So they have said here in the manual that you may just need another type of metals to cross this. I think it is metal 2 or metal 3 up to metal 6. You can use any of them, and you can you have here also the vias to make it more yeah. So let me hit home here in the bad frame. This is the ground, I think, and the bad in, and here is the out. This is the output. This is the bad in, and here I have the VDD. So you can see I have 1, 2, 3, 4 line, one for VDD, one for the ground, one for the output, and finally one for the input. Now, when you click the DRC, it's no point to click this at this stage because you just added the bad frame, and the bad frame has a lot of issues inside it. I won't go deeper now. In SPR or in the automatic place and route here SPR, the frame will just use the minimum number of pads. For example, we have here 4, so it will just use 4 only. But here I cannot modify the pad because it will create a lot of problems. And I based on some references from the internet, you can see here they do it like what I have did. They just connect it manually like this without removing anything from the bad frame. So let me close this. Yeah, you can see here he is using some technology and he is connecting to these two 3 pads or maybe 4 plus this is the core, and he is using only this portion of the bad frame, and this is empty. So it's no point to modify the bad frame. Let me go back to my design. So you will do the same thing. You will just do extract setup, and you will name the extraction, and finally you hit extract. It will extract to you. It will take a long time, maybe 2 minutes to extract the whole chip. Then after that you will just end up with the spice file. I have it already here, and you can see it's lengthy, but here you'll just add like what we have did the VDD. You include library and the input and the plotting commands. And here, for example, we are using 1.8 technology, and we have the minimum width for the NAND, or whatever width for the NAND we are specifying. Also for the MOS and PMOS. And here we are calling the bad frame subcircuit. It's from the extraction itself. I didn't modify it. And the ring oscillator, which is the core. So the core, the bad frame. Then you will just pass the input, ground, and the output of it. Let me check it. Okay. So here you can see the output is really a ring oscillator, and this period is where the run is not active. When you make the ring oscillator active, it will start from this point of time, and it will oscillate. But again here, even we are losing in terms of the voltage. So the wave cannot go. Yeah, it is almost 1.8 volt. But again, يعني it is not in the its expected oscillation. So the low is the high is very small, low seems very small, bit larger than the high. But anyway, it's due to the size. The sizes that we are using here, the minimum size for the inverters and also for the NAND itself. But here you can see the bad frames. All of this bias code is coming from the bad frames. So that's it for the full custom, and I hope you enjoyed the video. I'm sorry for the sound if it is not clear. Thank you very much, and see you again.